Hey, so today we are looking at similar triangles, not congruent shapes, right, but similar shapes. So that means they're not exactly the same, because we know congruent means the same. So they're not exactly the same, but they're very, very similar, meaning they're almost the exact same, okay? So when we look at these two triangles, triangle ABC and triangle DEF, we can say that they are similar and that they have corresponding angles and sides. When we look at this, we can see here, we've got a little X in this corner, an X in this one, and a dot up here, and a dot. And this is a 90-degree box. 90 degrees, it tells us it's 90 degrees. So we know that these angles are actually the same. Dot, dot, same. X, X, same. We know these are both 90s. So when we're writing out about these, we can say triangle ABC corresponds to triangle DEF. And then as we go through, this marker's kind of crap. As we go through, we can start to identify how they're similar. And we say, not an L, but this is an angle sign. Angle A, we'll keep them in capitals, that's what I have up there. Angle A equals angle D. And then we say angle B equals angle E. And finally, angle C, right here, equals angle F. So we can say that those angles are exactly the same, or they're congruent. We know that. But when we look at the sides, we can see that the sides are different in length. We have a smaller triangle and a bigger triangle, right? When we go through and we look at it. But when we're trying to say that they're corresponding or that they're similar, we end up writing it like this. Line segment AC corresponds to line segment DF. Line segment AB corresponds to line segment DE. And line segment BC corresponds to line segment EF. Now, it's really simple to look at this and see the difference between the two. We can say, okay, A to C and D to F have measurements already listed. We can say this is 8 centimeters and this is 16 centimeters. What's the difference between the two? Yep.
The biggest triangle doubled in size.
Yeah, D and F doubles in size, or it's times 2. It's 2 times bigger than this one. Would we be able to figure out what these other sides are then?
Yeah.
What would you say, Katie? If A to B is 6 centimeters, what would D to E be?
12 centimeters.
12 centimeters. Cruz, I see you got your hand up. If B to C is 10 centimeters, what would E to F be?
20 centimeters.
20 centimeters. That's pretty simple, right? Very, very simple, very, very easy. If we're thinking, and we're going to talk a lot more about this later on in ratios, the way that we write this is important. But if I was thinking in my head, how much bigger is this triangle than this one? I might write it something like this. I might write D to F over A to C. And then if I was to then write that out with the numbers that I have, I could say 16 over 8. If I did this as an actual division question, 16 divided by 8, what does that equal? What is 16 divided by 8? 2. We can go through the bigger triangle to the smaller one, and we can see how much bigger this triangle is than this one by simply using our fractions and dividing skills. So we can say 16 divided by 8 is 2, or we can say this triangle is 2 times bigger than our other triangle. Okay? What we want to be able to do come the end of our practice questions, we want to be able to identify how these triangles correspond, how they're similar, which sides are similar. We want to be able to say which angles equal each other. And we want to start to be able to figure out, using some numbers, what the other sides that might not be labeled are. And that's what we're looking at when we're looking at similar triangles. Similar triangles, right, or similar shapes in general, are the same shapes. They're just bigger or smaller. Their angles are all going to equal. If their angles don't equal the same, they're not a similar shape, right? It might look similar, like if we had this shape here, but we had something that looked like this, not similar, right? It's a different shape. It's not similar, it's different. So far we've learned about congruent shapes. Now we've got similar polygons, similar shapes, in this case, looking at similar triangles. Anybody have any questions? No? Hopefully you don't either. But if you do, message me on Edmodo. Ona!